Howdy, my name is Trent Blahuda, and today we're going to be looking at the results of the litter survey we have taken this semester. So to begin with, we can look at a graph or a map of both locations. Here we can see both the Shell Beach location and the Boat Basin location, which is the areas that I surveyed. They are both on the southern side of Pelican Island, as we can see, and the surveys were conducted on February 26th and 27th of 2023. Looking closer at Shell Beach, we can see where the highlighted area shows the actual ground that I covered when surveying the trash. And we can once again see the blue marker representing that's where Shell Beach is at in comparison to Pelican Island. Now the yellow shaded area is the area surveyed, and we can see that that was 2,220 meters squared. Once again, these surveys were conducted on the same dates, February 26th and 27th. Next, we have the Boat Basin, which is just to the east of the Shell Beach. Once again, we can find the yellow highlighted area to be where I surveyed the trash, and the Boat Basin blue marker in the middle representing this location. Once again, surveyed on February 26th and 27th. And the area of this location that was surveyed was larger than Shell Beach with 5,700 meters squared. Now we can find some proportions of total litter by material. On the left pie chart, we can see at the Boat Basin, there was almost 90% of the litter was carbon, 7% was metal, and almost 4% was silicon-based litter. So obviously a high level of carbon. And on the other hand, we can see Shell Beach has 93% carbon litter, 4.2% metal, and 2.8% silicon. So a slightly higher carbon level there. Here we can see litter graphs by category. On the left, we have litter by density. So here we can see the amount of litter that was per square meter. Beverage being the highest category at both Shell Beach and the Boat Basin, where the Shell Beach is over 0.15 pieces of beverage per square meter. And on the right, we have pieces of litter total. Beverage was once again the highest, with most plastic bottles and things of that nature, with some other and food, plastic bags, things like that. Here we have the identification table. We have three main categories: carbon, metal, and silicon. There's multiple things for carbon: plastic and foam; metal, fishing hooks, aluminum can; and silicon, a glass bottle and a gasket. And there are formulas and components of that. So to begin with carbon, a plastic bottle would take about 450 years to decay, and styrofoam would take a little more than that, which is 500 years to decay. They're not very easily degradable, and there can be harm to the environment, as animals can mistake the plastic for food and eat them and die. And as they decompose, chemicals can be released into the soil, which make long-term effects. Metal is similar, where aluminum takes about 200 to 500 years to decay. Steel takes about 1,000 years to decay. And they are once again not easily degradable. Animals can eat aluminum and contaminate soil when the metals degrade. Similarly, silicon is the same idea: glass with 1,000,000 years to decay and rubber with 250 years to decay, also providing harm to the environment. Here we can see some impact on the environment. In recent decades, plastic pollution of the ocean has been steadily increasing. It has become one of the major threats to marine life due to the chemical properties plastic can persist for decades and continuously accumulate in the ocean, said Eric Berard, which proves the point of how it's harmful to the environment. Indeed, heavy metal contaminants have become a worldwide problem. The uptake as well as accumulation of the aeriforous metals by plants and the main factor responsible for these threatening the health of both man and animal into their food by toxic metals, says R.K. Upadhyay. This just further proves the environmental impact. Here's my work cited. Thank you for listening.